Assalamualaikum, hi everyone. So this is a video for chapter 10, carboxylic acids and its derivative. So in this video, we're going to discuss on the subtopic 10.3, physical properties of carboxylic acid. The first physical properties that we're going to discuss is the boiling point. Okay, so for boiling point, all the boiling points before, okay, the points untuk boiling point yang kita dah belajar sebelum ni dalam alkane, okay, and then the one that we did in alcohol, okay, it's also valid in here. Okay, dan akan ada pertambahan beberapa point sahaja. Okay, so for boiling point of carboxylic acid, okay, it will be higher than alcohol, ketones, or aldehyde of similar molecular size. Okay, this is because carboxylic acid exists as a stable dimers through hydrogen bonds. Okay, molecules in dimers are arranged closely packed, therefore the hydrogen bonds in carboxylic acid are relatively strong and higher energy is needed to overcome the intermolecular force. Okay, now, so dekat sini, okay, macam saya cakap, faktor-faktor lain yang mempengaruhi molecular weight, okay, and then awak ada dia punya branching, okay, and type of intermolecular force. Okay, now, yang itu if you are comparing within the same carboxylic acid, maksudnya antara carboxylic acid dengan carboxylic acid. Okay, but for this one, kita discuss dulu, kita comparekan between alcohols, ketones and also aldehyde. Okay, kenapa kita pilih tiga ni? Okay, this is because untuk alcohol, okay, the intermolecular forces is the same as carboxylic acid. It can form hydrogen bonds between its molecules. Ketones and aldehydes, dia cuma ada dipole forces sahaja, okay, between its molecules. Okay, now, so dekat sini, kenapa carboxylic acid has the highest boiling point among all of the substance? Okay, dalam exam, jawapan yang awak akan tulis untuk carboxylic acid adalah you're going to write down carboxylic acid will exist as a stable dimers through hydrogen bond. Mesti exactly the word as it is macam ni. Okay, carboxylic acid stable dimers through hydrogen bond. Okay, apa yang dimaksudkan dengan stable dimer dekat sini? Okay, so ni tadi, therefore the boiling point of carboxylic acid is higher. Okay, macam mana bentuk dimerization of carboxylic acid? Okay, so dekat sini, we have two carboxylic acid. So this is the carboxyl group C double bond O, OH. So dekat sini nanti yang akan terhasilnya awak punya hydrogen bond. So we will have two hydrogen bond. Kenapa kita panggil dia dimer? Sebab bentuk, this is the shape of a dimer. Yang mana kita ada dua compound. Okay, and then it is linked together by two hydrogen bond. Okay, dan membentuk satu dimer. So, since it has two hydrogen bonds here, it is very high boiling point because you need a very high energy to overcome this hydrogen bond compared to kalau kita ada dalam alcohol. Okay, macam saya cakap tadi, alcohol also have hydrogen bond. But dalam satu alcohol macam ni, dalam satu molekul alcohol, antara alcohol, okay, it can only form satu saja hydrogen bond dekat sini. Yes, dekat sini akan ada hydrogen bond. Dekat sini pun akan ada this part and this part. Okay, but dia macam ni, hydrogen bond yang senang nak putus. Compared to this one, you will get a dimer. Nanti kat sini pun boleh juga ada hydrogen bond. Sini pun boleh juga ada hydrogen bond. Same goes with here. Okay, per molecule itself, per atom dekat sini, okay, ada dua. Dekat sini cuma ada satu. So, sebab tu carboxylic acid has higher boiling point. Okay, jadi macam saya cakap tadi, kalau soalan minta explain kenapa, ni, awak akan kata carboxylic acid exists as stable dimers through hydrogen bond. This is the most important explanation. Okay, jadi lepas tu yang second one ni awak tak letak pun tak apa. Awak terus kata higher energy is needed to overcome the intermolecular forces. Okay. Ini exist as stable dimers through hydrogen bond. Mesti ada hydrogen bond dekat sini. Okay, let's look at an example. So, arrange the compound in order of increasing boiling point and explain. Okay, so kita ada tiga compound yang berbeza dekat sini. Okay, so apa yang awak kena buat adalah first, okay, awak kira dia punya bilangan karbon. Okay, kemudian check the molecular forces. The type of intermolecular forces, and also the molecular weight. So if you look over here, the molecular weight is comparable. Maksudnya dia lebih kurang sama. 130 gram per mole untuk this carboxylic acid, 128 gram per mole for this aldehyde CHO, and 130 gram per mole untuk kita punya alkohol dekat sini. Okay. So, once kita dah tahu berat dia lebih kurang sama, so you cannot use the factor of molecular weight untuk tentukan dia punya boiling point. Okay, jadi faktor apa yang kita akan gunakan? Kita akan gunakan faktor intermolecular force. So, awak tentukanlah type of intermolecular force. So, pada carboxylic acid, dia ada London forces, dia ada dipole-dipole, dia ada hydrogen bond. Okay, tapi yang awak akan ceritakan adalah the most significant intermolecular force, which is hydrogen bond dekat sini. Okay, untuk kita punya aldehyde dekat sini pula, okay, the type of intermolecular forces that it has is London forces and also dipole-dipole forces. Okay, jadi yang signifikan adalah dipole-dipole forces saja. So, kita dah nampak dekat sini. Okay, kita punya aldehyde sekarang ni dah jadi yang paling rendah boiling point dia because it only has dipole-dipole forces. Okay, next kita tengok pada alkohol. So, alkohol pun ada tiga-tiga. London forces, dipole-dipole and hydrogen bonding. Okay, jadi the most significant is hydrogen bond. Okay, so masalah dia sekarang adalah ada dua compound yang ada hydrogen bond, which is our alcohol over here and our carboxylic acid. So, bila ada hydrogen bond, jadi kita tengok macam mana bentuk hydrogen bond tu tadi. Okay, so as you know, the highest boiling point, okay, will go to carboxylic acid, followed by alcohol, and last sekali yang paling rendah dia punya boiling point adalah aldehyde. Okay, jadi dekat sini dia suruh arrange in increasing order of boiling point. Okay, so dekat sini kalau dalam exam dia bagi awak structure, the question give you structures, you can label them as A, B, C. Okay, so, contoh dekat sini saya dah buat A, B, C, increasing boiling point. So, awak letaklah A tu siapa? A is our aldehyde, B is our alcohol, and C is our carboxylic acid. Okay, jadi macam mana awak nak explain boiling point? So, you need to explain one by one. Okay, so nyatakanlah compound A, okay, has the lowest boiling point sebab apa? Compound A only form dipole-dipole forces between their molecules, while compound B and C form strong hydrogen bond between their molecules. Okay, dekat sini awak mesti nyatakan yang hydrogen bond ni adalah strong. Okay, kalau awak just kata compound B and C form hydrogen bond saja, okay, dia takkan menunjukkan apa-apa. Kenapa dengan hydrogen bond tu? Kenapa kalau ada hydrogen bond, boiling point lagi tinggi? So that's why you need to mention the word strong hydrogen bond to show that hydrogen bond is stronger than the dipole-dipole forces. Okay, so yang ni explanation yang pertama. Explanation yang kedua, kita akan kata boiling point of compound C is higher than compound B. C is higher than B. Tadi mula-mula kita cerita kenapa A paling rendah. Okay, kemudian kita cerita kenapa C paling tinggi. Kenapa C lagi tinggi daripada B. Okay, sedangkan dua-dua form hydrogen bond. So, this is because compound C exists as stable dimers through hydrogen bond. And molecules in dimer are arranged closely packed. Okay, so therefore the hydrogen bond of compound C is stronger than compound B. So, mesti ada comparison of the strength of the hydrogen bond. Sama juga ada kat atas ni. Comparison between the strength of intermolecular forces. Okay, jadi ini je lah jawapan yang awak akan bagi. Okay, simple. So, mana-mana, katakan, like I mentioned, kalau dia melibatkan type of intermolecular forces yang berbeza daripada compound yang berbeza, okay, macam ni lah awak akan jawab dia. Okay, so let's proceed with the second physical properties. Kita akan bincangkan solubility in water. Okay, so ingat, okay, bila kita cerita tentang solubility in water, so untuk for a compound to be soluble or miscible in water, it must able Okay, to form hydrogen bond. So kalau dia boleh form hydrogen bond, I mean the organic compound can form hydrogen bond with water molecule. Okay, so maksudnya dia boleh soluble dalam water. Okay, so kita tengok macam mana dengan carboxylic acid. Okay, so carboxylic acids are soluble in water due to the formation of hydrogen bonds, okay, between the water molecules and also the carboxylic acid molecule. Okay, so macam ni lah. Okay, as you can see over here, so yang dekat sebelah sini, okay, saya highlight kan. Okay, this part, okay, this is your carboxylic acid. Okay, and then dekat carboxylic acid, okay, pada carboxyl group itself, on the carboxyl group, okay, pada oxygen dan juga pada hydrogen dekat sini, it can form hydrogen bond with your water molecule. So ini adalah water molecule awak. Okay, jadi disebabkan dia boleh hasilkan hydrogen bond with water molecule, so our carboxylic acid is soluble in water. Okay, tetapi the solubility of carboxylic acid in water is almost the same as alcohol. So ingat balik, okay, alcohol also soluble in water. Sebab apa? Dia boleh form hydrogen bond. Tapi bukan semua alcohol boleh soluble in water. Okay, until 5 carbon alcohol sahaja yang boleh soluble in water. Okay, so as the number of carbon atom increases, carbon atom dekat sini dia refer kepada kita punya alkyl group dekat sini. So as the number of carbon atom increases, solubility of your carboxylic acid in water will decrease. Okay, carboxylic acid having carbon less and equal to 5 are water soluble. So maksudnya kalau ada 5 carbon, which is your pentanoic acid, it is soluble in water because they can form hydrogen bond with water molecule. Okay. Yang kalau 6, contoh hexanoic acid, tak boleh ke dia form hydrogen bond? Boleh dia form hydrogen bond, but remember the hydrophobic area is too large. Okay, jadi hydrogen bond tak mampu menampung dekat sini. Kiranya the hydrophobic area outweigh dia apa? Dia kiranya dia overcome the hydrogen bond dekat water dekat sini. Okay, water molecule ni pun tak besar mana. So, bila hydrophobic area lagi besar, jadi hydrogen bond dekat sini nampak macam insignificant. So, that's why it is insoluble in water once you have 6 carbon and above. Okay. So, ni yang saya ceritakan tadi. Carboxylic acid having carbon more than 5 are water soluble. Maksudnya 6 carbon lah. Okay, because the non-polar alkyl portion is too large to dissolve in the polar water solvent. Okay, so in conclusion, as the size of the alkyl group increase, the hydrophobic area will increase, thus the solubility of your carboxylic acid will decrease. Okay, so ni dah tadi. Your hydrophobic area, your hydrophilic area. Walaupun kita ada hydrophilic area yang boleh form hydrogen bond, but once the hydrophobic area is too large, okay, this portion cannot be soluble in water sebab dia terlampau besar. Jadi, the whole molecule akan jadi insoluble in water. Okay, so aromatic carboxylic acid are slightly soluble in water due to the huge aromatic ring. Aromatic carboxylic acid awak adalah apa? So basically your benzoic acid. So kalau kita cerita aromatic, okay, confirm kita akan cerita tentang awak punya benzoic acid. Okay, dia only slightly soluble saja. Dekat mana? Dekat part carboxyl group dekat sini lah. Okay, the very big aromatic ring over here yang ada surface area yang sangat besar sebab dia adalah planar. Okay, so it is insoluble in water. Okay, dicarboxylic acids are relatively more soluble since more hydrogen bond can be formed. So, katakan awak ada 6 carbon. Okay, initially 6 carbon is insoluble. Okay, tetapi when you have a dicarboxylic acid, contoh awak ada hexane dioic acid. Okay, so maybe solubility of hexane dioic acid will be better compared to kalau dia cuma hexanoic acid saja. Okay, kenapa hexane dioic di ada 2 is better? Because it can form more hydrogen bond. Lagi banyak hydrogen bond dia boleh form, so dia punya kadar ketelarutan, ability to dissolve in water will also increase. Okey, masih lagi kita cerita tentang solubility, so physical properties yang kedua. Okey, tapi sekarang kita akan cerita solubility in non-polar solvent. Okay, so basically, carboxylic acids are soluble in non-polar solvents such as benzene due to the van der Waals forces between the benzene and alkyl group of carboxylic acid. So, kena ingat, mana-mana structure dalam dunia ni, okay, confirm dia akan ada London forces. Okay, so London forces can form van der Waals forces. Okay, then London forces adalah a type of van der Waals forces. So, dia boleh larut dalam mana-mana organic solvent. Okay, even though dia boleh hasilkan hydrogen bond, tapi hydrogen bond is only important when we are talking about solubility in water. Okay, selain daripada tu, all organic compound will dissolve ataupun soluble in non-polar solvent. Okay, sebab ni lah tadi. Okay, sebab ada van der Waals forces. So, ini yang saya maksudkan tadi. Okay. Ada hydrogen bond, tapi hydrogen bond akan exist between molecule. Ini kalau kita masukkan awak punya carboxylic acid dalam benzene. So, benzene dekat sini, ini adalah solvent. This is carboxylic acid. Okay, jadi, part mana yang akan form van der Waals forces? The alkyl group, the hydrophobic area. Okay, yang ni akan form van der Waals forces dengan benzene yang menyebabkan dia boleh dissolve dalam benzene. Now, the third physical properties of our carboxylic acid yang kita akan tengok adalah the acidity. Okay, acidity ni sebelum ni kita dah pernah discuss dalam alcohol. Okay, where we compare acidity of alcohol with water and also phenol. Okay, so sekarang kita jumpa lagi acidity dekat dalam awak punya carboxylic acid. Okay, so a carboxylic acid dissociates in water to form H3O+ ion and also carboxylate ion. Okay, jadi carboxylic acid dia boleh bertindak sebagai acid. The name itself is an acid. Okay, cuma dia adalah weak acid. Okay, jadi sebab tu dissociation dia akan gunakan reversible arrow. Okay, because it's a very weak acid. Okay, so the acidity of carboxylic acid will be influenced by two things. Okay, the first one is the resonance effect. The second one is the inductive effect. Ini maksudnya acidity. Okay, kalau kita cerita tentang acidity, awak kena fikirkan juga tentang ability of your carboxylic acid to release H+. Okay, lagi senang dia release H+. Okay, saya note dekat sini. Okay, so easier to release H+. Okay, maksudnya kita akan ada stronger acid. Okay, kalau lagi susah dia nak release H+, okay, you will have a weaker acid. Kiranya vice versa lah dekat sini. Okay, jadi the acidity of carboxylic acid, macam saya cakap tadi, bergantung kepada dua benda, kepada dua effect. Satu resonance effect, satu lagi adalah inductive effect. Okay, so carboxylic acid, like I mentioned, is a relatively weak acid. It's relatively a weak acid. However, carboxylic acid is stronger than phenol and alcohol. So, kalau sebelum ni kita susun, susunan kita adalah macam ni. Okay, alcohol is the weakest. Okay, and then followed by water. Okay, kemudian phenol. Okay, so OH kat sini sebab tak mahu letak kat atas. Okay, dengan adanya awak punya carboxylic acid will be the strongest acid between these four weak acids. Okay, jadi yang paling strong adalah awak punya carboxylic acid. Okay, so dekat sini. So ni lah kat sini sebenarnya, ada dekat sini. Okay, so yang ni, kalau yang ni susunan daripada lowest acidity to highest acidity. So, kalau yang ni pula daripada strongest acid to your lowest acid. Okay, so yang ni just nak tunjukkan dia punya acidity. Kita tengok dekat acid dissociation constant dia. So, the bigger the value of the acid dissociation constant, maksudnya awak akan ada stronger acid. So if you look over here, carboxylic acid 10 to the power of negative 5, your alcohol 10 to the power of negative 16. So yang inilah yang paling tinggi. Okey, jadi sekarang kita akan tengok faktor yang pertama yang mempengaruhi acidity of carboxylic acid. So the first factor that affect the acidity of carboxylic acid dekat sini adalah kita punya resonance effect. Okey, apa resonance effect yang kita akan tengok dekat sini? So, carboxylic acid are more acidic than our phenol and also aliphatic alcohol due to the resonance stabilization on the carboxylate ion. Okay, jadi nanti kalau dalam explanation, okay, kalau soalan minta cerita tentang acidity, so kita tengah compare between alcohol, phenol dan juga carboxylic acid. Okay, jadi jawapan yang pertama yang awak akan tulis adalah carboxylic acid. Inilah carboxylic acid is more acidic than phenol and aliphatic alcohol. Kalau ada nama alcohol tu letak kat situ. Due to the resonance stabilization of the carboxylic ion. This is the exact word yang awak kena tulis. Resonance stabilization of carboxylate ion. Okay. Apa resonance stabilization of carboxylate ion yang kita ada dekat sini? Okay, yang ni just explanation saja. Dalam exam tak perlu tulis. Enough you just write this down. Okay, but if let's say the question asks you to show the resonance stabilization. Okay, resonance stabilization tu akan berlaku dekat mana? Okay, so your carboxylic acid bila dia dissociate in water, like I mentioned before, kita akan dapat carboxylate ion. So this carboxylate ion akan ada resonance structure. Okay. So, resonance structure dia adalah disebabkan, kalau awak tengok dekat sini, okay, kita akan fokus kepada kita punya oksigen. Okay, so lone pair. Okay, and then dekat sini akan ada 3 lone pairs. Okay, so this lone pairs, okay, this lone pair of electron, okay, dia boleh delocalize. So, dia akan delocalize ke mana? Okay, jadi dekat sini, the 2 electrons go here, the other one go over here. Okay, jadi the negative charge asalnya dekat sini, the negative charge on this oxygen, okay, sekarang ni dah pindah kepada oksigen yang kedua. So the negative charge is being transferred. Okay, being shared between 2 oxygen dekat sini. Okay, jadi the negative charge in carboxylate ions are delocalized between 2 oxygen atom. Jadi awak kena faham, oxygen atom adalah electronegative atom. Okay, oxygen electronegative. Okay, so in other words, kalau ada electronegative atom, dia boleh accept electron better. Okay, dia suka untuk terima elektron. Jadi, bila kita ada atom yang suka terima elektron, kita punya negative ion will become more stable. Okay, so bila dia become more stable, it will be easier untuk H3O+ terhasil. Contoh macam kat sini kan, okay, bond akan break dekat mana? The bond will break over here. Okay, so sebabkan kita tahu kita boleh dapat carboxylate ion yang sangat stabil, the oxygen-hydrogen bond over here will become weaker. Okay, weaker compared to your phenol and also your alcohol. Lagi weak dekat sini. So, dia sangat-sangat ready untuk release H+, untuk jadi H3O+ dekat sini. So, that's why, okay, our carboxylic acid is stronger acid. Okay, compare to our phenol. So in phenol, the phenoxide ion form is stabilized also by a resonance effect. Okay, cuma beza dia dekat sini. Okay, kalau kita tengok dekat sini, okay, so this is the stabilization for your phenoxide ion. Okay, kita ada resonance structure juga. Daripada negative charge pada oksigen, kita delocalizekan dia ke dalam kita punya benzene ring. Okay, but the phenoxide ion is less stable than carboxylate ion because it has only one electronegative oxygen atom. Okay, so kalau awak ingat balik dekat structure, so saya lukis kat atas ni. Okay, structure phenol oxide ion awak. So negative charge initially berada pada oksigen. Okay, and then this negative charge, okay, dia being delocalized into the benzene ring. Dia di-share dengan siapa? Share dengan carbon atom. Okay, so satu electronegative atom, satu oksigen dan juga another 4 carbon. Compared to your carboxylate ion. So R, C double bond O, O minus. The negative charge on this oxygen, on this particular oxygen, okay, kita share dia between oksigen lagi satu, between dua atom yang memang sangat suka elektron. Compared to this one, yang sangat suka elektron sebenarnya siapa? Oksigen saja. Carbon ni dia just passkan around saja. Okay, so that's why dekat sini, okay, phenol oxide ion akan jadi less stable dari carboxylate ion lah. So kalau awak nak explain, explanation dia awak just tulis ini je. Phenol oxide ion is less stable than carboxylate ion because it has only one electronegative atom. The negative charge is delocalized into the benzene ring. Kalau carboxylate ion tadi, awak akan cakap the negative charge in carboxylate ion are delocalized between two oxygen atoms. Okay, dan kalau kita nak compare dengan alcohol, alcohol ion is less stable than phenol oxide ion because it does not stabilize by resonance. Okay. Dan awak boleh kata, awak boleh tambah dekat sini, the negative charge. Okay, so saya tambah kat sini, the negative charge, okay, is localized. Okay, is localized on the oxygen atom only. Okay, jadi bila dia tertumpu dekat oksigen atom, satu oksigen atom saja, ion yang awak akan hasilkan tu adalah less stable. Okay, so sebab tu dia akan jadi less acidic lah. Okay, so therefore aliphatic alcohol is less acidic than phenol. Okay, jadi kalau dalam exam, if the question asks you compare the acidity between carboxylic acid, alcohol and also phenol dan juga water, okay, apa yang awak akan buat adalah, okay, first susun dulu. Okay, susun carboxylic acid, phenol, water, alcohol. Yang ni ikut ni decreasing acidity. Kalau dia minta increasing, awak buat terbalik lah. Okay, kemudian explanation. Jadi explanation yang pertama, you're going to explain compare between carboxylic acid and juga phenol. Okay, jadi ayat yang awak akan tulis adalah, okay, so you're going to write it down like this. Okay, so ayat yang pertama, okay, carboxylic acid is more acidic than phenol. Okay, so sambung dekat sini. Okay, due to the resonance stabilization of the carboxylate ion. So the negative charge in carboxylate ion are delocalized between two oxygen atom. So tu statement yang pertama. Statement yang kedua, okay, awak akan tulis, okay, in phenol oxide ion. So phenol oxide ion maksudnya kita refer kepada kita punya phenol. Okay, phenol oxide ion, it has only one electronegative oxygen. Okay, so the negative charge is delocalized into the benzene ring. Okay, so itu statement yang kedua. Yang ketiga, okay, awak akan kata alcohol. Okay, saya letak dekat atas lah supaya statement dekat atas. Okay, yang ketiga, awak akan tulis alcohol is the least acidic. Okay, because, so awak nyatakanlah. Okay, because it does not stabilize by resonance. Okay, kalau awak nak tambah, boleh tambah statement yang keempat dekat sini. The negative charge, okay, negative charge on alkoxide ion. Okay, on alkoxide ion is localized. Okay, perkataan dia localized only on oxygen atom. Okay, tapi sebenarnya enough kalau awak stop sampai statement yang ketiga saja. Okay, jadi inilah yang awak akan tulis dalam exam. Okay, so this will be it. So nanti awak try, okay, write on a piece of paper jawapan. Kiranya this is actually your marking scheme. Kalau dia compare between different classes of compound. Carboxylic acid, phenol, water dan juga alcohol. Water tak perlu explain. Dia akan jadi dekat situ. Okay, so masih lagi dalam acidity tapi sekarang ni kita tengok effect faktor yang mempengaruhi acidity yang kedua, which is inductive effect. Okay, so what is actually inductive effect? So substituent that stabilize the negatively charged carboxylic ion will increase dissociation and result in stronger acid. So in other words, inductive effect ni adalah, kalau sebelum ni okay, kita cerita tentang electron withdrawing group dan juga electron donating group. Okay, so kita ada dua dekat sini. Yang saya dah terangkan dekat awak dulu when we did our chapter 4 is electron donating group. Inductive effect dekat sini adalah kiranya ability of that particular compound, particular group, either untuk dia donate to increase electron density ataupun ability dia untuk tarik electron density. Okay, so itu kita cerita tentang inductive effect, induce. Okay, so if you have an electron withdrawing group, so an electron withdrawing group EWG will reduce the electron density of electrons at carboxylate group. Okay, and stabilize the carboxylate ion. Okay, so maksudnya dekat sini. Okay, so yang ni awak punya carboxylate group. So carboxylate group kita tadi kan kita ada negative charge, meaning we have a high electron density. Okay, jadi kalau electron density dekat sini kurang, okay, the electron density over here kurang, okay, so awak kena ingat O minus dekat sini dia akan attracted dengan H+. Okay, so like I mentioned just now, untuk acidity, okay, kalau lagi senang dia nak release H+, lagi kuat dia sebagai acid. Okay, easier to release H+, the stronger the acid. Okay, jadi dekat sini, kalau electron density rendah, maksudnya attraction of the negative charge towards the hydrogen ion is weaker. Electron density rendah, tarikan negative charge kepada positive ion weak. Maksudnya lagi senang untuk release H+, so you will get a stronger acid. Okay, so sebab tu dekat sini lah. Okay, jadi kalau awak ada, if you have an electron withdrawing group, the acidity of your carboxylic acid will increase. Okay, compared to if you have an electron donating group. Okay, when you have an electron donating group, EDG, it will increase the density of electrons at carboxylic ion. Electron density dekat sini akan tinggi. And it will destabilize the carboxylate ion. Okay, sebab kita tahu lagi negatif dia, lagi tinggi electron density, lagi unstable your structure. Okay, itu satu. And kita boleh juga tengok in terms of bond dengan H+. Attraction dengan H+. So, kalau electron density tinggi, okay, so attraction of your negative charge dekat sini terhadap H+ akan become stronger. So, bila lagi stronger, maksudnya apa? Dia lagi susah nak release H+. Lagi susah nak release H+. So, it will become less acidic. So, effect of electron withdrawing group. Okay. Jadi, dekat sini, electron withdrawing group. Okay, first, kita kena tahu lah apa kita punya electron withdrawing group. So, example, nitro, fluorine, chlorine, bromine, iodine, the halogens. Okay, so basically dekat sini nanti explanation dia is all the things that I have mentioned just now. Cuma dia bertulis kat sini lah, so you can read it better. Okay, so an electron withdrawing group reduce the electron density on oxygen atom in OH. Dia akan fokus pada OH saja. Kenapa kita fokus dekat OH? Sebab dekat sini lah nanti H+ akan release. Okay, H+ akan release untuk jadi asid lah. H+ ion akan jadi H3O+ ion later. Okay, jadi thus the oxygen hydrogen bond becomes weaker and hydrogen ion can be easily released. Okay, jadi kalau electron density pada O at this particular O is lower, the oxygen hydrogen bond lagi senang nak break. Okay, this oxygen hydrogen bond dekat sini easier to break. Okay, lagi senang hasilkan H+. So maksudnya awak akan ada a stronger acid lah. Okay. So, example, I have over here a 2-chloropropanoic acid dan juga propanoic acid. Okay, so apa beza antara kedua-dua acid ni adalah, okay, number of carbon dia sama. 1, 2, 3. Kat sini. 1, okay, 1, 2, 3. It's a propanoic acid. The difference is, pada chloropropanoic acid, kita ada chlorine. Okay, so we have an electron withdrawing group. Okay, located near to the carboxyl group dekat sini. Kalau dekat sini, tak ada apa-apa. Cuma ada alkyl group saja dekat sini. Jadi, awak akan explain, kalau kita compare between these two, you will explain, chlorine, nyatakan dulu, chlorine is an electron withdrawing group. Therefore, it will reduce the electron density of oxygen in OH-. Awak akan tulis exactly as this is. Okay. As is it yang ada dekat sini, itulah yang awak akan jawab dalam exam. Okay. Thus, the OH bond becomes weaker and H+ can be easily released. Therefore, 2-chloropropanoic acid has higher acidity than propanoic acid. Okay, jadi effect of electron withdrawing group. Okay, so yang ni kita compare. Okay, ingat so dekat sini awak kena take note. Okay, comparison dekat sini kita compare. Compare same number of carbon. Okay, so same number of carbon and number of carboxyl group. Okay, jadi kalau ada carboxyl group dia satu sama, so kalau ada satu halogen dekat sini, okay, jadi kita explain macam ni lah. Okay, kita bagi tahu dengan adanya electron withdrawing group, acidity akan increase. Okay, syarat dia ni. Okay, mesti number of carbon sama, bilangan carboxyl group pun adalah sama. Okay, yang seterusnya adalah masih lagi pada effect of electron withdrawing group. Okay, tapi sekarang case-nya adalah, okay, kita ada number of carbon yang sama. So, syarat dia kat sini. Okay, syarat dia number of carbon is the same. Number of carboxyl group pun sama. Okay. Jadi, awak tengok kat sini 1, 2, 3. 1, 2, 3. So, dua-dua adalah sama. Dan, kedua-dua carboxylic acid, okay, mempunyai, it contains, dekat sini, at the second carbon, at the same position. Okay, saya highlightkan dekat sini. So, dekat sini, dia mesti berada, okay, same position. Okay. Wujudnya electron withdrawing group. Kita ada chlorine, kita ada fluorine. Okay, jadi dekat sini explanation awak tak boleh macam tadi. Kalau macam tadi, compare between a normal carboxylic acid dengan satu lagi carboxylic acid yang ada electron withdrawing group. But this one, both has electron withdrawing group. Jadi macam mana awak nak explain? Awak nak compare macam mana? Compare between the electronegativity of the electron with drawing group. Okay, fluorine, chlorine, electronegativity berbeza. Okay, jadi awak akan tulis dulu both fluorine and chlorine are electron withdrawing group. Okay, tapi awak nyatakanlah tentang electronegativity dia. So, electronegativity of fluorine is stronger ataupun higher than chlorine. Jadi, the electron density on oxygen of OH in 2-fluoropropanoic acid is less. Sebab apa? More electronegative, dia akan tarik electron density lagi kuat compared to kalau pada chlorine dekat sini. Okay, so the electron density on oxygen of OH in 2-fluoropropanoic acid is less. Thus, the OH bond is weaker in 2-chloropropanoic acid. So therefore, H plus is easily released. Okay, then awak akan beritahu lah. Thus, 2-fluoropropanoic acid is more acidic than 2-chloropropanoic acid. So yang ni is either awak nak letak dia dekat atas ataupun awak nak jadikan dia statement yang terakhir. Tak kisah. Okay. Jadi, conclusion dekat sini, kalau ada electron withdrawing group, okay, dua-dua ada electron withdrawing group, so kita akan pilih effect of electronegativity. Type electronegativity of the electron withdrawing group. The more electronegative this substituent, the acidity of acid will increase. Tapi syarat dia dekat sini, tadi bilangan karbon mesti sama, bilangan carboxyl group pun mesti sama, dan satu lagi, okay, yang kedua, so satu lagi adalah position, okay, of electron withdrawing group is the same. So kalau dia dekat carbon, kalau structure yang pertama, electron withdrawing group kat carbon nombor 2, the second one pun mesti dekat carbon nombor 2. Kalau dekat carbon nombor 3, so the second one pun mesti dekat carbon nombor 3. Barulah adil, okay, untuk compare. Okay, seterusnya adalah effect of number of electron withdrawing group attached. Okay, so example, I have 2,2-dichloropropanoic acid dan 2-chloropropanoic acid. Okay. For this one, syarat dia adalah, okay, masih lagi syarat yang pertama, number of carbon is the same. Okay, yang seterusnya, number of carboxyl group is the same. Yang seterusnya, syarat dia adalah type of electron withdrawing group mesti sama. Maksudnya, if you are using chlorine, semua mesti guna chlorine. Okay. Dia tak boleh dekat sini awak guna chlorine, dekat sini awak guna bromine. So, dia tak valid. Okay, sebab apa? Kita nak compare the effect of number of electron withdrawing group. Jadi, guna electron withdrawing group yang sama. In exam, dia akan bagi yang sama. Dia tak akan bagi yang berbeza. Kalau berbeza, maksudnya syarat yang tadi. Okay. Syarat dia, number of carbon sama, carboxyl group sama, kedudukan electron withdrawing group yang sama, cuma yang beza dia adalah jenis. Okay, so kalau yang ni lah. Okay, so chlorine. Semua guna chlorine. Okay, cuma dekat carbon nombor 2, for this one, we have 2 chlorine. Dekat sini kita ada 1 sahaja chlorine. Jadi awak dah boleh fikirlah, oh, electron withdrawing group. Lagi banyak electron withdrawing group, lagi banyak elektron dia boleh tarik, lagi kuranglah electron density dekat your carboxyl group over here, dekat OH over here to be particular. Lagi senang, lagi weak oxygen hydrogen bond, easier to release H+, a stronger acid. Yang tu awak dah boleh buat dah flow dia dekat dalam kepala awak. Okay, mental thinking orang kata. Okay, so awak akan tulis jawapan. 2,2-dichloropropanoic acid contains 2 chlorine that make the OH bond weaker Ingat kita fokus pada OH bond. Okay, then 2-chloropropanoic acid with only one chlorine atom. Thus, H plus is easily released. Maksudnya easily released ni dekat mana? Dia refer kepada 2,2-dichloropropanoic acid. Okay, so therefore, the 2,2-dichloropropanoic acid is more acidic than 2-chloropropanoic acid. Okay, jadi kita boleh buat conclusion. The larger the number of electron withdrawing group attached, the acidity of the acid will increase. Maksudnya kalau ada lagi satu klorin dekat sini, lagilah kuat dia akan tarik electron withdrawing. Dia akan tarik electron density pada OH dekat sini. Okay. Last sekali, masih kita bincangkan effect bila kita ada electron withdrawing group. Kita akan tengok effect of the position of the electron withdrawing group. Okay. Contoh saya ada dekat sini 2-chlorobutanoic acid dengan 4-chlorobutanoic acid. Okay, syarat-syarat dia. Okay, so syarat yang pertama macam yang awak dah tahu. Okay, mesti same number of carbon. Yang kedua, same number of carboxyl group. Yang ketiga, same type of electron withdrawing group, same type and number. Bilangan dia kena sama. So kalau guna satu, dua-dua structure kena guna satu electron withdrawing group. So kalau ada dua, awak kena guna dua and mesti electron withdrawing group yang sama. So ini syarat dia. So if you look over here, 4 carbon, 1, 2, 3, 4 butanoic acid. Cuma for this one, okay, the chlorine, okay, is located at the second carbon. Okay, tapi kalau dekat 4-chlorobutanoic acid, okay, the chlorine is located at the fourth carbon. Okay, so position dia berbeza. Okay, jadi apa effect position dekat sini? Lagi dekat the location of the electron withdrawing group kepada carboxyl group, lagi kuat dia boleh tarik. Yang ni dia boleh tarik, tapi dia kena melalui 1, 2, 3 halangan dekat sini. Okay, jadi dia boleh tarik tapi susah sikit. Okay, jadi macam tak efektif lah. Okay, it's not really effective di electron withdrawing yang chlorine buat dekat sini. Okay, jadi awak akan kata the distance between chlorine atom and carboxyl group in 2-chlorobutanoic acid is nearer. Awak akan kata dekat sini lagi dekat, is nearer than in 4-chlorobutanoic acid. So, sudahnya awak akan cerita pasal apa? You going to tell about the OH bond. So, the OH bond in 2-chlorobutanoic acid is weaker than in 4-chlorobutanoic acid. Kenapa tadi? Sebab electron density kat sini dah tarik. Kat sini tarik, tapi tarik sikit je. So, masih lagi tinggi electron density over here. So, that's why the H plus is easily released dekat mana? Dekat sini. Thus, therefore, the 2-chlorobutanoic acid is more acidic than 4-chlorobutanoic acid. Jadi, conclusion yang ada dekat sini adalah, okay, the closer the electron withdrawing group to the carboxyl group, acidity of acid will increase. Tapi syarat dia apa tadi? Mesti gunakan halogen yang sama ataupun electron withdrawing group yang sama dan bilangan dia pun mesti sama. Okay, last but not least, kita akan cerita tentang effect of electron donating group. Okay, so your electron donating group paling senang kita akan fokus kepada alkyl group sahaja. Okay, jadi lagi banyak alkyl group, lagi tinggilah effect of electron donating. So contoh dekat sini, okay, kita compare between ethanoic acid and propanoic acid. Okay, syarat dia satu je. Okay, syarat dia adalah number of carboxyl group, okay, mesti sama. Same number of carboxyl group. Jadi yang akan berbeza nanti adalah dekat bahagian belakang ni lah. Okay, the alkyl group dekat sini. So, alkyl group is an electron donating group. Yang ni kita dah pernah belajar sebelum ni. Sebab dia ada banyak elektron dekat sini. Electron density pada alkyl group adalah tinggi. Okay, jadi the size of alkyl group in propanoic acid is larger than in ethanoic acid. Yang ni kita nak terus compare. Jadi maksudnya dekat sini kan tadi kita mention tentang inductive effect kan. Okay, so kalau inductive effect dekat sini, bila ada electron donating group, okay, electron density inductive effect dia akan berlaku. Electron density daripada alkyl akan dimasukkan ke dalam carboxyl. Okay, kat sini lah. Jadi, bila lagi besar alkyl group, lagi banyak electron density yang dia boleh pump, yang dia boleh gerakkan ke arah carboxyl group. Okay, so that's why the size of alkyl group in propanoic acid is larger than in ethanoic acid. So, ethyl dekat sini is a stronger electron donating group than methyl. The electron density in OH group, jadi conclusionnya mesti cerita pasal electron density dekat sini. Ni. Dekat sini ni electron density. Okay, kita akan cerita. The electron density in OH group in propanoic acid increases and H+ is difficult to be released. Sebab apa? Electron density tinggi, tarikan kuat. Therefore, ethanoic acid is more acidic than propanoic acid. Electron density kat sini tadi tinggi. Sebab alkyl group dia lagi besar. Maksudnya lagi panjang alkyl group awak, lagi banyak elektron yang dia boleh pump ke sini, yang dia boleh gerakkan untuk increase electron density over here. Lagi kuatlah tarikan antara oksigen dan hidrogen. Okay, jadi in conclusion, the presence of electron donating group will decrease the acidity of the acid, and the larger the electron donating group, the acidity of your carboxylic acid will decrease. Okay, jadi in conclusion, kalau kita cerita tentang acidity of carboxylic acid, okay, so mula-mula tadi kita cerita tentang resonance effect. Okay, so resonance effect yang mana yang awak compare between carboxylic acid, phenol, water and alcohol. Yang kedua, kita cerita tentang inductive effect. So kalau inductive effect, kita kena tengok. Okay, kalau kita cerita, adakah kita akan cerita tentang electron donating group ataupun electron withdrawing group. So kalau kita cerita tentang electron donating group, okay, electron donating group akan donate electron. Donate electron akan increase the electron density. Okay, so electron donating group awak adalah alkyl group, so dia akan destabilize the carboxylic ion. So the presence of electron donating group, acidity akan decrease. Okay. Okay lah. And then kalau ada increase number of carbon lagi banyak, so lagi rendah lah awak punya acidity. Okay, kemudian kita cerita pula tentang electron withdrawing group. Okay, so in general, electron withdrawing group akan stabilizekan awak punya carboxylate ion. Okay, so kalau ada awak compare electron withdrawing group with carboxylic acid yang ada electron withdrawing group dengan yang tak ada, the one with electron withdrawing group, EWG, is more stable. Okay, kemudian kalau carboxylic acid dua-dua ada electron withdrawing group, baru kita akan tengok 3 efek dekat sini. The first one, effect of electronegativity. The more electronegative the electron withdrawing group, okay, jadi dia boleh attract electron more towards itself. The electron density pada OH group akan berkurang, will decrease, acidity will increase. Okay, kemudian number of electron withdrawing group, mesti pakai electron withdrawing group yang sama. So, as the number of electron withdrawing group increase, okay, jadi electron withdrawing group boleh tarik electron towards itself, menyebabkan electron density on the OH group decrease. easier to release H+, so acidity akan increase. Dan yang terakhir, the position of the electron withdrawing group. Kita tengok compare kepada distance. Distance antara electron withdrawing group dan carboxylic group. The nearer the distance of electron withdrawing group with the carboxylic acid, lagi dekat, okay, jadi acidity akan jadi lagi tinggi. And vice versa. Kalau kedudukan dia lagi jauh, tarikan elektron, okay, by the electron withdrawing group, daya tarikan dia akan kurang. So, the OH bond, the electron density on the OH bond is higher. So, bila lagi tinggi, lagi kuatlah tarikan dia. Okay, so yang itu adalah conclusion of everything that we have discussed so far. Okay, so this is all for your physical properties of carboxylic acid. Thank you very much for listening until the end. So I hope everything that we have discussed is beneficial for you. Okay, thank you guys.